Hello, everyone. Before I get started, a little bit about Stripe. Stripe's mission is to increase the GDP of the internet, and we do that by building economic infrastructure that allows businesses large and small to accept payments around the world. And that mission is a little easier to achieve if we're able to give Amazon less of our money. So how do we do that? Today we're here to optimize costs, but really what I want to do is frame this cost optimization problem as an observability problem. Just like we can use charts and metrics to measure our API performance, we can do the same to measure the effectiveness of our efficiency program. I did my market research when it came to putting together this talk, and it shows me that emojis are the most effective way to get y'all engaged. So there's 109 of them in this talk. The central thesis here is that in the cloud, cost and performance are aligned. All the resources that we buy in the cloud are metered, so we can choose how much performance and how much cost we spend in order to make our application run smoothly. The sort of high-level goals I hope you take away from this talk are to sort of describe some techniques we can use to measure AWS cost at scale. We'll get into a little bit what scale means for us. Next, we'll talk about purchasing reserved instances for maximum savings. These things account for about half the savings you can get from AWS, so we're going to spend lots of time here trying to understand them. And finally, we're going to talk about how we can build sort of organizational level competency around cost optimization and building an efficiency program that works both technically and culturally with your organization. Just a reminder that this is an observability problem. Just like we measure the P99 latency of our API with charts and metrics and time series, we can do the same for our costs with a metric source and time series there as well. So a little bit about Stripe scale with AWS. We have hundreds of host types. A host type is roughly a individual workload that corresponds to a virtual machine role or a puppet role. We have lots of servers. And in our history, we have over 1 billion AWS billing line items. What is a line item? Well, for each hour that we consume resources on AWS, we get a bill for individual resources bucketed by SKU. Just like in the on-prem world, you might have a SKU for your R640 database server. AWS has SKUs for everything that they sell too, from minutes of instance time on an i3 4x large to number of X-ray traces stored to gigabyte months of S3 per particular bucket that we're using. So if we want to add observability to our costs, we need a metric source. We need some sort of time series that we can look at to derive some insights about the data. For that, we're going to use the cost and usage report. This is a report that AWS publishes to you for free, believe it or not, that contains an hourly log of every billing line item that you've had in your account. This includes things like the type of resources you're buying and how much of them. These SKUs are going to come up again. So these are sort of the high-level fields that allow us to decide what we care about from each of these line items. There's some usage type. This is the SKU I've been talking about. Here, we're looking at a i3 4x large instance that is launched in the US West 2 region. Associated with each line item is a usage amount. Here it's 0.52 instance hours. Probably means we just spun up this VM within the last hour or so. The units for these vary depending on the SKU. So for EC2 instances, it's time. For S3, it's gigabyte months. For X-ray, it's number of traces. And then the last important thing here is the cost. We want to associate these SKUs with how much they're actually billing us for them. There's a bunch of ways we can measure this cost. We'll get into that in a little bit, but for now I'm just hoping you take my word for it that 0.52 instance hours of an i3 4x large costs about 65 cents. One thing that's cool about thinking about our bill in terms of individual line items is that we can take these line items and attribute costs associated with them to various other components of our infrastructure. We can take this particular line item for an individual i3 4x large and attribute it to a team or a product or a bit of infrastructure that we care about. The cost and usage report is pretty big. It has about 200 columns in it, which gets even crazier when you consider that AWS allows you to pipe through arbitrary custom metadata from your AWS tags into this report. Basically what I'm trying to say here is don't try and deal with this thing yourself, load it into Redshift. AWS exports this report in a format that makes it a one command import into your Redshift data warehouse, and you should leverage that. Be prepared to write some SQL to work with this data. We have an ETL that scans our S3 bucket for this report and uploads it into our Redshift cluster daily, so we can have an up-to-date measure of our costs. Tying the actual columns in the report to these high-level characteristics that we care about, the usage type lives in this line item usage type field. Similarly, usage amount, this is the amount of the resource that we've consumed. And the pricing is kind of this weird thing that doesn't look like the rest of them in this pricing public on-demand cost column. What is this? Why is it not a line item? Why are we using this weird notion of pricing? And the reason is because AWS exposes lots of different measures of pricing, and we're going to ignore two of them off the bat because the unblended cost and the blended cost are lies. You should not trust them at all. Basically, these two bad measures of cost depend on sort of the vagaries of your billing setup with AWS, your reserved instance workloads, and the discounts that you might have available to you from Amazon. All of this means these measures of costs fluctuate wildly depending on the current state of your infrastructure, and they even vary within individual instance types. This makes it really confusing when you're trying to build an efficiency program and hoping that folks can compare their costs to each other. So instead, we use this public on-demand cost. Like its name implies, it is the list price that you can get just as a random new customer for AWS. This is the price that you'll see on their public pricing page. We like it because it doesn't vary with reserved instance footprint or anything like that. And it allows each team and each workload to directly compare their costs with each other. $1 of C5 9x large over here is directly comparable to an R5D 24x large over there. I'm going to talk a little bit about tagging now because it's important. If you want to be able to measure your costs on anything resembling a dimension that's customized to your business, you want to have tags associated with your resources that you pass through in the cost and usage report. This is my minimum recommended set of tags. Sort of going in increasing level of granularity, we have VPC. This is the cluster that your infrastructure is associated with. Owner, this should be a team that owns the infrastructure. Cost center, a more granular definition of owner. And the host type, which corresponds to those workloads that I was talking about earlier. The reason you want to include these tags on your infrastructure and in the cost and usage report is the same reason you include tags and properties on your metric time series in your observability stack. Having the data denormalize allows the querying to be much simpler. While I can join the cost and usage report with the AWS config and the VPC flow logs to figure out all of these related bits of metadata, it's like really annoying and I don't want to have to hurt myself in order to do that. So instead, we include everything on each of our resources and pipe them through to the cost and usage report. We use these tags, particularly owner and cost center, to allow us to attribute the spend associated with these different resources to individual owners and cost centers in a process we call cost attribution. This is, you may have heard of this referred to as a showback reporting or chargeback reporting before. It's a mechanism for allowing business units to pass costs between each other, which means that even though I run the database infrastructure for the whole company, I can shard that cost out among the consumers of those resources. So now that we've got sort of our metric source, we have this cost and usage report that we're going to be able to slice and dice by all these different dimensions. This allows us to answer some fun questions like how many servers do we have and what type are they and how are those affecting our costs. This right here is a chart of our instance footprint bucketed by instance family over the past 90 days or so. It's interesting that this is bucketed by instance family instead of by instance type. And the reason we do that is to cut down on metric cardinality. If we're looking at both instance type and instance size, that's kind of like an n-squared classification problem, which makes the reporting a little more difficult. How do we avoid that? The way we do that is through normalization. I want to make a quick note that this purple line over there, the dark purple one on the top, is trending down, while this sort of light blue line that you can hardly see is trending upward. Those are I3s and R5Ds respectively. We'll get into a little later what that actually means. So the way we do that normalization to allow us to report only the instance family is with this thing I call X-large equivalence, which gives me an excuse to put some t-shirt emojis on the screen. Basically, we're taking advantage of the fact that in AWS, regardless of the type of pricing plan we're on for EC2 instances, costs scale linearly with the size. An i3 2x large is half as expensive as an i3 4x large. This means we can normalize all of our instances on any one size. We choose X large and only do the reporting on costs for that size. This is super nice because it cuts down one of the dimensions in the metrics and allows us to directly compare across teams with similar workloads that use the same family but maybe not the same size. So that's sort of the whirlwind tour of the cost and usage report and how we use it as a metric source. Let's dive into reserved instances a bit and see how we can save a bunch of money for free from AWS. To level set a little bit, a reserved instance is a contract that you can enter with AWS that allows you to get an effective hourly discount on a EC2 instance in exchange for committing to that instance for some period of time. We think that of all the savings you can extract from AWS, reserved instances account for at least 50% of all those savings, so it's worth spending some time to understand them and use them correctly in your infrastructure. In terms of specific discounts you might be able to get, they are up to 52% for any one instance family. This 52% number comes from a C5 X large 3-year, no upfront convertible RI. It's kind of a lot to unpack there. C5X large is this normalized size that we're talking about of a C5 instance family. 3-year means we're committed to having that server for 3 years. No upfront means we have no capital outlay in order to get this reserved instance. Instead, we pay that discounted hourly rate on a monthly basis. And convertible means we can, at any time, exchange this particular reserved instance for one of any other instance family. Say I stop using C5s for one particular workload and switch to i3s, I can change this reserved instance over to an i3 at no additional cost. That being said, the process of buying these things is a little non-trivial. We sort of lie at the confluence of cloud strategy, bin packing, and capacity planning here. And there's some high dimensionality to the search space that's a little bit difficult to handle. What does that high dimensionality look like? It looks like this. There's 13 dimensions to any reserved instance purchase. The orange ones are the decisions that Amazon makes you make when you click, click, clack on your keyboard to make the purchase in the console or via the API. And the blue ones are the decisions that we, as Stripe, make in order to feel comfortable about making a reserved instance purchase. Luckily, we're not alone here. We at least know the answers to some of these problems when we start out. Hopefully, you know which region your servers live in, you know what OS they run, and you know whether or not you use dedicated instances. Right off the bat, we can lock in 3 of these 13 dimensions. The next sort of big decision we can make is to use regional scope for our reserved instances. When reserved instances first came out, they were only zonal, which meant they were tied to a specific availability zone. And you got a capacity guarantee in exchange for this lack of flexibility. We don't really care about capacity guarantees because they only work at the edges. They require you to reserve more servers than you're actually using for them to be effective. Otherwise, you're just reserving capacity you've already spun up. Because we don't care about this, we can trade away this feature with zonal RIs for something called floating RIs if we switch to a regional scope. This means our AZs are pegged to US West 2 instead of US West 2A. And all of the reserved instances can float as our capacity migrates between availability zones. Additionally, using the regional scope gets us something called instance size flexibility, which allows us to apply the same X-large normalization technique we're using for the reporting to the reserved instances themselves. Now, we can only buy reserved instances for the X-large size and have them cover any size within that instance family. This cuts down the dimensionality of the search space and eliminates one of those decisions we needed to make. We locked in a few more dimensions with that, notably no capacity assurance, the instance size, and the scope. We're going to delegate to the finance team for the next set of decisions here because things like the contract term, the ability to exchange versus seeking the maximum discount, and the payment plan depend on things like the financial health of your company, appetite for vendor risk, and willingness for capital outlays. All these sorts of decisions are sort of in the ball court of the finance team, so we're going to delegate those to them and lock in a few more dimensions. For context, at Stripe, we choose 3-year convertible and no upfront because we believe that gives us the best trade-off of optionality versus cost savings. So we locked in all these dimensions across the top here. Let's move on to a little bit more engineering work and talk about when and how many of these things we should buy. The way we compute our purchase bundle is to automate the process with a batch job. We analyze the cost and usage report, that metric source that we're talking about, and take snapshots of our fleet on a daily basis to detect what is our current RI footprint and how many servers do we have, and sort of mash those together to figure out how we're doing in terms of coverage and compared to our coverage target. What's a coverage target? I find this best to describe with an example. A coverage target means for the C5 instance family, I have 90% of the instances applied on RI2. Coverage targets are useful because they allow us to measure our effectiveness as the efficiency team, and they make finance's job much more predictable. Then we fire some alerts to kick off a manual purchase. Manual because I don't really want to be paged when I make a several $100,000 or $1 million purchase on the wrong set of instances. So we have some manual approval steps where people actually click buttons to make sure that we're within budget and making the right purchases. We locked in a bunch more dimensions. Now we just have one left, this pesky ownership thing. To determine who should own RI purchasing, it's useful to know how Amazon treats these things. They are allocated globally across your account, which means in order to not under-purchase, it helps to have these things centrally owned. The efficiency engineering team that I'm a part of owns making these purchases for the whole company across all of our AWS accounts. Sweet, we locked in all the dimensions. Now let's move on to figuring out how we can build a culture of cost competency in our company. We think, just like the reserved instance purchasing, that cost optimization is a global problem. So let's dive into some techniques we can use to make some technical optimizations to save us some money. In order to make sure that we are right-sizing correctly, Goldilocks for servers instead of for bears, we make sure that we pick the right size instances. Too big and we're wasting on cost, too small and we're wasting on performance. One way we did this was by looking at our Hadoop workloads and determining we could make that shift from I3s to R5Ds to better align with our disk usage across these two. We turned off a bunch of servers because the cheapest servers are ones that are turned off, and this also let us better align the process with our global offices to make sure we were spinning up CI workers in a follow-the-sun pattern. And finally, we were able to save about half of our AWS costs on our Hadoop nodes by consolidating our clusters into a single AZ to cut down on crosstalk related to HDFS. Thank you very much.
So how do you enforce that all the resources are properly tagged with the dimensions that you mentioned?
The short answer is we don't have a good answer for this. There are some cloud governance tools that can help enforce that proper tags are set. I think there's one from Capital One that I've heard about. Another good option if you're just starting out is AWS Organizations has a feature that allows you to block resources from being spun up with IAM if they do not have a certain set of tags associated with them. But that's not really useful if you already have infrastructure already.
I have other questions. So I see a Terraform sticker. Do you use Terraform to set up like resources tags and stuff? Like modules, pre-built?
Yeah, we've been using AWS for quite a while. So we have also some legacy mutable infrastructure that does not use Terraform. It uses custom tooling. But most of the foundational bits of our infrastructure, like VPCs and stuff, are built with Terraform and all tagged this way.
Great talk, thank you. Are individual teams within Stripe incentivized to cut down on their cost? Like, how do teams use this data?
Yeah, so we publish some scorecards that allow folks to see how they're doing in comparison to all of their peers. And one cool thing that I like about these scorecards is that the efficiency team is able to manipulate them in order to derive the behavior we want in the organization. Say we no longer want to support M3s because they're legacy hardware that are like expensive for us to maintain operationally. We can like artificially hike up the cost of these things to make it more painful for folks to run, even though there's no actual money moving around as a result of this.
Thank you.
Hi, this is Naman. So as of now, what issues we are facing in our AWS billing is because mainly I'm maintaining the AWS charges and the cost optimization report. So what day-to-day issues what I'm facing is like take example of bunch of 1,000 servers. So when I'm pulling up a report from the cost uses, it doesn't show me like what instance belongs to RI and what instance doesn't belong to RI. So that's the biggest problem. My manager asked me, okay, Naman, these are the 10 instances. Tell me right now what belongs to this RI. Then I always give the answer as a no. I don't know. I do research on bit on that. So do you have any like a shortcut way or any way like which can pinpoint, okay, this machine belongs to RI?
Yeah, so like the way AWS allocates these things is like very much like a black box. They
Exactly,
they
yeah.
kind of like randomly decide which ones get an RI tag to them versus not, and that can change on an hour-to-hour basis. The way we solve this problem is to take a look at sort of all of our instances weighted on an X-large basis for like our C5s, and we look at all of our RIs on C5s, chunk everyone's share up by the team tag, and like allocate RI savings from the big pool of RIs. It's like really much a pain in the ass, and I hate doing it.
Exactly. Okay. So that's the one question, and the second one is the pricing. So there's a last column in the AWS cost user that is amortized and blended, unblended. So I'm not sure like what section do I need to click on because sometimes it shows me $0, and it's completely crazy. How come it is possible? I'm paying only $0 for a machine. So that's another confusing point for me. Like I don't know which type I need to select, and I refer some AWS docs, but none of them help.
Yeah, so as your reserved instance coverage goes up, the blended cost goes, or the unblended cost goes down, or something. One of these things is like a weighted average, and one is like an effective price that sorry. I get confused about this too, which is why I had the slide in the middle with the X's on it, because I hate these things. But
so in a short, like which type I need to select? Amortize, total amortize, or which one? Like they have plenty of options over there.
I don't know, sorry.
Because these are the real life pain points in our organization. Like day to day, I need to solve them. Like my manager keep on asking me, "Naman, give me the price." I don't know. I don't have answer for that every time.
We just totally ignore all of these cost things from AWS and take that public price and then layer on all the discounts that we know about after the fact.
Okay, so that means take a price from the on-demand and take the price of your instance and compare the difference. Like, okay.
And like we compute what the expected reserved instance discount that we're expected to see is, and what the expected enterprise discount is that we expect to see, and like sort of like layer them on like a P&L statement.
Okay. So there is no clear picture about that also. Okay, thank you. Thank you so much for answering.
Hey, thank you for your talk. Do you guys have a process for deciding whether to like deprecate things you guys have built yourself and for AWS managed resources? Like we have Elasticsearch clusters that we've been managing for a bunch of years, and now it's like managed by AWS. Do you guys have a process for determining expenses, whether it's like abandonment expenses or PropEx?
This is more a question about like what our strategy for the cloud is, and I think what we try and do is only use commodity type things from AWS. So RDS we're totally okay migrating onto, and are continuing to migrate things onto RDS because we'd rather outsource this operational burden. Same thing for stuff like ELBs. Like our like edge network was originally all custom built, and moving it onto ELBs eliminates a lot of that maintenance burden from us. This also means though that we prefer to self-host like Mongo as opposed to using DocumentDB, just because this is a differentiated offering that we don't know if we'd be able to replicate elsewhere. Thank you, everyone.